It's all around us. Let's take a look at the carbon cycle, specifically carbon stores. So the carbon cycle plays a key role in balancing the Earth's systems. Carbon is stored in the atmosphere, on land, and in oceans, and is moved between these by various processes. The carbon cycle. This is a closed system, so there are no inputs or outputs in the carbon cycle. There are three parts: stores, where carbon is held; fluxes, the flows of carbon between different stores, these differ in size; and processes, which are the physical ways in which carbon fluxes happen. Carbon stores are measured in petagrams of carbon, otherwise known as PGC. The hydrosphere, which is about 38,000 PGC, dissolved in carbon dioxide in bodies of water. The lithosphere, 100,000 PGC, rocks like calcium carbonate and fossil fuels. The biosphere, 2,000 PGC, animals and plants, dead and living. And the atmosphere, 750 PGC, which is gases like carbon dioxide. So the hydrosphere is dissolved CO2 in bodies of water. The atmosphere is gases like CO2. The lithosphere is rocks like calcium carbonate. And the biosphere is dead and living plants and animals. Now let's have a look at biochemical carbon stores. Carbon is found across our world in different forms: as a liquid, dissolved in bodies of water, for example; as a gas, like carbon dioxide; and as a solid, like calcium carbonate. Terrestrial. Carbon is found within every living organism on the planet. On the land, every plant and animal is an example of a carbon store. When plant and animal matter decays, it can be converted into other carbon stores by going into the soil. Other terrestrial carbon is stored within the mantle and can be converted into atmospheric carbon by the process of outgassing by volcanoes, where they let out carbon dioxide during eruptions. The role of organisms. So there's our photosynthesis. Plants remove carbon dioxide from the atmosphere to produce energy for plant growth. Respiration. All living organisms release carbon dioxide as they breathe and grow. Decomposition. When living organisms are broken down, releasing carbon dioxide into the soil. Combustion. The burning of biomass or fossil fuels, both by man and in natural wildfires, releases carbon dioxide back into the atmosphere. Oceans. Aquatic plants and animals, organic matter, fall to the ocean bed after death. Due to compression and cementation, they form into sedimentary rock. During these processes, crude oil and natural gas can form. Atmosphere. Carbon dioxide is stored as a gas in the atmosphere. Carbon can leave the atmosphere when mixing with water vapor. When precipitation happens, this causes carbonic acid, which is commonly referred to as acid rain. Fluxes vary in size. The carbon cycle can happen at different scales and time frames. The quickest cycle is completed in seconds during photosynthesis, but it can take years for dead organic material to be returned. Some organic material will be buried in the sea and form in sedimentary rock, which is an extremely slow process. Let's quickly recap all of that. Different modes of organisms in the carbon cycle. Combustion, the burning of biomass or fossil fuels, both by man and in natural wildfires, releases carbon dioxide back into the atmosphere. Photosynthesis, plants remove carbon dioxide from the atmosphere to produce energy from plant growth. Respiration, all living organisms release carbon dioxide as they breathe and grow. Decomposition, when living organisms die, they are broken down, releasing carbon dioxide into the soil. So quickly recap that. As part of the carbon cycle, aquatic plants and animals fall into the ocean floor after death. Here they are formed into sedimentary rock due to compression, and which other process? That process is cementation. During these processes, crude oil and natural gas can form. Let's have a look at geological carbon stores now. In the formation of sedimentary rock, carbon can be found in several different forms, including limestone, crude oil, coal, and natural gas. Formation of limestone. Phytoplankton have carbon-based shells. Other marine organisms also have shells or skeletons that are formed from calcium carbonate. When these aquatic organisms die, they sink to the bottom of the ocean. As more sediment falls on top of them, they are compacted. When the sediment has reached around 100 meters in depth, the pressure and chemical reactions cause sedimentation to take place, which leads to the formation of limestone rock. Formation of natural gas. Methane, otherwise known as CH4, is an example of natural gas and is created as a byproduct during the formation of coal and crude oil. Natural gas is trapped in the same sedimentary layers of coal and around them. Formation of coal. Coal is formed on land, unlike limestone and sedimentary rock, which are formed in the oceans. When land-based plants die and enter into swamps, they slowly settle and compact to form peat and coal. Coal takes millions of years to form, depending on the temperatures and pressures. Formation of crude oil. Crude oil starts with the settling of fine-grained sediments and biologically degraded materials. there needs to be a minimum of 2% organic carbon. A series of anaerobic reactions, so reactions that happen without oxygen, happen to turn the majority of organic carbon into a liquid. This is crude oil. Due to its light density, crude oil may migrate upwards through layers of permeable or porous rock, but a layer of impermeable rock will result in the crude oil being trapped. So let's quickly recap that. What is an example of a natural gas and is created as a byproduct during the formation of coal and crude oil? This is methane. Coal is formed on land. When land-based plants die and enter swamps, they slowly settle and compact to form what, as well as coal? Correct answer is they form peat. Coal takes millions of years to form. Exactly how long this process takes depends on the temperatures and what other factor of the surroundings. Depends on the temperatures and the pressures. Now let's have a look at geological processes that release carbon. Carbon can be released into the atmosphere via the rock cycle. So chemical weathering of rocks. Chemical weathering is the wearing away of rock by chemical reactions, causing material to dissolve through solution, hydrolysis and oxidation. Slightly acidic rain, a carbonic acid, forms from carbon dioxide in the atmosphere being dissolved into rainwater. When acidic rain hits carbon-rich rocks like limestone, it can dissolve material and form calcium carbonate. These dissolved materials are then transported down rivers and deposited into the sea, forming intersedimentary rock. There's also volcanic outgassing. Extreme heat from tectonic processes leads to sedimentary rock undergoing chemical changes, causing carbon dioxide, CO2, to be released into the atmosphere. Volcanic activity happens at two types of plate boundaries. Constructive plate boundaries, where two plates move apart. Destructive subduction zones, where an oceanic plate subducts under a continental plate. Volcanic activity at these plate boundaries causes CO2 to be released in outgassing, which is common in geothermal locations like New Zealand. So slightly acidic rain, which is a carbonic acid, forms from carbon dioxide in the atmosphere being dissolved into rainwater. And when this hits carbon-rich rocks like limestone, it can dissolve material and form calcium carbonate. Which gas is released in the atmosphere in outgassing of volcanoes? This is carbon dioxide. Carbon is found within every living organism on the planet. On the land, every plant and animal is an example of a carbon what? This is an example of a carbon store. Other terrestrial carbon is stored within the mantle and can be converted into atmospheric carbon via the processes of outgassing by volcanoes, where they let out carbon dioxide during eruptions. What are the processes involved in the formation of crude oil? Well, impermeable rock will be trapped in the crude oil. Impermeable rock results in the crude oil being trapped. There's a settling of fine-grained sediments and there are anaerobic reactions. And that's not in the correct order, but these are the different processes that happen. What are fluxes in the carbon cycle? Are they where carbon is held, the flows of carbon between different stores, or the physical ways that carbon flows happen? Correct answer is that the flows of carbon between different stores.